Here we are for our fieldwork day as part of the summer school that we're running out here in Chernobyl. We've come to the village of BioAcoustic, which sits on the western trace of the Chernobyl contamination area within the exclusion zone. The western trace is located just over here. It spans about 800 metres at this point, so you can go from a very low dose rate to quite a high dose rate in a very short space of time. We've brought the students here so they can see what an abandoned village looks like, and later on we'll be able to show you around that abandoned village. They'll be able to see how nature has captured that village back, and they'll have the opportunity to undertake 3 different projects around the village. One project will be about the forest that's near us, and they'll be looking at the trees. There'll be another project where they're looking at leaf pigments, and then a final project where they're doing things to do with the bioacoustics and the camera work. So this is a map of the Chernobyl Exclusion Zone. It shows the distribution of the contamination within the zone, and at the time of the accident from the reactor, which is here, there was a spread of contamination out, depending on which direction the wind was blowing at the time. So there was a spread up to the northeast. You can see this higher red patch here denoting the higher levels of contamination. We have what's called the western trace, which is a narrow band of contamination extending out to the west, and also a spread down to the south here. Within the wildlife study that we're doing using the cameras and the acoustic monitors, we have sampling locations in the green low contamination area here. This area that cuts across the western trace, a broadly medium level area, or medium contamination area, and a high contamination area up here to the northeast. We are in Chernobyl town at the minute, at Sergei Gaschak's house within the town. We've already been to Pripyat and taken the students to look around Pripyat, and we've also been and looked at the reactor. Today we're going to be heading up and over to the village of BioAcoustic, also known as Beetroot Village. That's the translation of BioAcoustic. And at this location, at this village, we're going to give the students the opportunity to see some of the effects of removal of people from a village environment, see how nature has taken that village back. We're going to have the opportunity to show them what it's like to work in the field, working across this western trace, this area where you move from very low contamination to quite high contamination over a very short distance. The width of that main part of the western trace of BioAcoustic is roughly 800 metres. So the students will have the opportunity to go across that transect and see the dose rate change as they move across the transect. So this is the site just through here that we've been using for studying what's going on by way of animal activity at BioAcoustic. Through there you can see a lamppost, old lamppost, or concrete post, which has got a grey box on it. That is the acoustic recorder that we've been using for doing the bioacoustic study of this locality. As we walk towards it, over on your left, low down you'll see a tripod that's been created out of sticks with a camera mounted on it. So that's the wildlife camera that's motion activated, and as an animal moves in front of it, hopefully the picture gets taken so we capture what animal was there at that time. So what we'll do is we'll walk over into this area, we'll have a look at what information these 2 pieces of equipment have collected, and we'll also have a bit of a talk about why we're using this equipment and what it's going to help us do by way of studying this environment. Okay?
The camera has been running since July. The sound meter was put here in July, but we set it so it went off for 8 days just before you arrived. So it will have done 8 days recording before whatever day we arrived, Wednesday. Okay?
We mount them at about 75 centimetres high for the lens. That is judged to be a height which will allow us to capture animals that are quite low to the ground, so raccoon dogs, foxes, things like that, we'll be able to capture the images of.
Quite close into the camera.
Yeah, but it will also allow us to capture larger animals, so moose that may be moving through, for example, we can capture those as well. Obviously, because of the height that it's set at, if you have a moose that's quite close in, all you see is a knee or something like that. So when you come to analysing and interpreting the photograph, you've got to be really good at recognising bits of animals, not just the whole animal itself. The camera, as I said to you before, is motion activated and also heat activated as well. It uses passive infrared sensors here and here. So these are pointing out over quite a wide field of view, and as a animal moves across, it'll trigger the camera, it'll take a picture. The camera can be set to take bursts of pictures at a particular time, so it'll do a burst of 3 photographs, and we can then retrieve the memory card from the camera at the end of the sampling period and have a look what we've got. So we shall do that now.
The cameras run for about 8 weeks, then we change the memory cards, and we actually change the location as well. Yeah, so the cameras move around.
Yeah, when we get the laptop out, I can show you the locations that we're using and talk to you a bit more about exactly how many positions we're using in each of those locations. And when we come to doing our population estimates, or estimates of population density, using this camera model, one thing that we have to recognise is that these are relative estimates. So it's an estimate for this location in our generally medium contamination area versus estimates from the high contamination area and from the low contamination area. They're not absolute population density numbers. It would be very dangerous to say that we were doing that because we just can't be certain enough in the model outputs. But it gives us something that gives us a relative comparison, so we can start to investigate whether radiation dose rate is actually influencing relative population densities across different areas of the zone. One of the things to bear in mind is that you want to capture as many pictures as possible of animals, but you don't really want to be capturing pictures of trees moving or plants moving or sun shining brightly and causing the camera to trigger as well.
Shadow through trees.
So all of these sorts of things will cause cameras to be triggered. So one of the things that we do is we carefully position the camera in a direction where we will minimise the amount of sunlight that's shining directly into the camera or causing sunspots, which will cause the camera to trigger and just give us a picture of the area with nothing in it as such.
Alright, can everyone see it?
Yeah.
Yeah? So this is obviously of a night. We did hear, on the sound meter, we could hear deer moving around, but we hadn't seen them. Amazing how many animals know the camera's there.
Yeah. He is not sure. She is not sure. I realised that as soon as it came out of my mouth.
The moose are the animals that seem to show most interest in them. Wild boar, totally ignore them.
Yeah.
Apart from the ones who use it as a scratching post and not the camera ski with. But don't take any interest in it otherwise.
Lynx have shown some interest in.
We've got a lynx
One that
climbing
climbed
all
up
over
and
it.
has a cuddle of the camera. If it's boiling hot, which it has been recently, you don't want to be doing a lot of moving around and foraging.
that's right,
You
you
want to try and stay as cool as possible,
Yeah.
and then you'll go out of an evening to go foraging.
Winter, we're getting lots of pictures in the day.
Yeah.
It's going down.
I see a change in the
Yeah.
pattern.
Yeah.
And we also see a
Throughout the year.
change in the types of animals that we see as well. So the numbers of raccoon dogs that we've seen in the pictures have increased quite a lot as we've moved into a warmer period, because during the winter period when it's really cold, raccoon dogs either hibernate or have very low activity. And this is one of the sorts of problems that you do encounter with fieldwork. You know, you can do your absolute best to set up something so that you've got a camera mounted which will capture the images that you want, but there's always something unexpected that can happen. Obviously the equipment can fail, but you've got animals that you're working with, so not surprisingly there's always the chance that they're going to knock something. As Nick said previously, we've had wild boar that have shifted camera angles, so we've got the camera set up pointing in the direction that we want. We actually, for the purposes of our modelling work, we use a grid of canes in front of the cameras to mark different distances away from the camera and then trigger the camera as we're setting the camera site up. And then that way we can create a grid in a photo editing package and overlay that onto the pictures that we capture from the camera, and we can tell how far away the animal is from the camera and calculate which angle it's approaching the camera from. So if the camera gets moved by an animal, clearly that causes a few problems with trying to do the mapping of grid onto photographs of the subsequent animals. Because obviously an issue with this is that you've got a 60-degree field of view.
Yeah.
So animals outside of that 60-degree field of view aren't photographed.
What
If you were
about
able
solar
to,
panels then?
well, this is all part of the sort of development of the technology. So you could use that, but you'd need a way of making sure that the 360 camera remained waterproof as you fed in the cable to charge it continuously. So that 360 camera that I've got is weatherproof, but you have to take the bottom off, which is where the rubber sealing ring is, to secure all the internals, to be able to put your charger cable in.
Undoubtedly it will be here, but
Yeah.
and soon, but
Yeah.
not just yet.
Yeah.
Some people double cameras up.
Yeah. Yeah, so you get cameras pointing
Pointing at
in
each
two
other.
opposite directions or pointing at each other.
So what is the actual range for the motion sensor? Because Nick, you just said that you could
Yeah,
things, but it
where
wouldn't
we've
be
got
triggered.
pictures of things that far away, it's probably been set off by something closer
Yeah.
as well.
Okay.
We've worked on these. If you are about 3 metres away, you need to be, I think, having a run of 9 metres each side of it to be able to be out of the zone and then moving in, triggering and moving across. There's a difference between whether you're trying to do a scientific study as such, or if you're trying to get good photographs and get an indication of what's there.
Yeah, I'll try and find out what's there. Yeah.
Yeah.
So Sergey has about 6 cameras of his own, and he positions those in places he knows he's going to see things. So position them near water holes, on bridges that animals have to cross on. So the bear was caught on a bridge. The photograph of the bear was on the bridge.
Is
Oh, there is
a
many plants.
Song Meter
I don't
3,
quite know what it is.
which is the
Looks like
wildlife
mint,
acoustics monitor and recorder that we're using here. No. It's got 2 omnidirectional microphones. We've got the left channel and the right channel, both of which are picking up sounds. So in here, we've got the SD memory cards. These, each of them, is a 32 gig card. So they're capturing a lot of data. But in actual fact, that doesn't translate into that much recording time, because it's capturing full sound spectrum. It takes a lot of memory. So we can't just set it to record for an 8-week period. It wouldn't last that long. It'll last maybe 8 or 9 days. So what we have to do is we have to program the song meter to come on at particular times during that 8-week period. We've currently got 4 of these operating in each of our 3 main study areas, the low, medium and high contamination areas. They are paired with some of the randomly located cameras. So the idea is that these are again part of a random sampling network. As these are paired with cameras, we are defining within the 4 song meters that we have a program 1 song meter, a program 2, a program 3 and a program 4. In each of the 3 study areas, the program 1 song meters all come on the same day and record for the same period of time and then turn off. Then the program 2 ones all come on, record for the same period of time and go off. So you can see that across each of the 3 areas we've got the same sampling pattern. So what we need to do is we need to stop the program. Who wants to stop the program? Well, somebody interact with the equipment rather than just me doing it. Go on, Robin. Okay, so you have a look at it and tell me what you think you need to do to stop the program.
Press the program stop button.
That sounds like a brilliant idea. I can tell you're
I
doing a
do it?
PhD. Go for it. Okay. Writing summary file. There you are. So the program's stopped. So now we can just turn the thing off. So there's a slide switch up there. So if you flick that up. Okay. And now that that's off, we can take out the memory cards.
Okay.
Now there are 4 cards in here. A, B, C and D. And they record in that order, so card A fills up first, then B, then C, then D. So if we just pop out card A, top one up there, that's it, pull it through, brilliant, thank you. And we'll grab the laptop, and have a quick look at what we've got. You can see spikes within the sound signal, and a general breadth to the sound signal as well. So if we come in and just choose a point here and start to listen, I'll turn the sound up for you. Every year, around the time of the accident, the anniversary of the accident, so 26th of April, people are allowed to come back in and they are allowed to visit the locations where they lived. And that's quite important, particularly for people that were from the villages, because if you imagine, as a villager, you were likely there as somebody that had a number of generations there previously living in that location, maybe even in the same house. So you're likely to have very strong ties to that location. Your parents, your grandparents may well be buried in the local cemetery, so your only opportunity to go and visit the grave and go and remember those aspects of your ancestry are when you get to come back in for that short period of time around the anniversary of the accident. So people come back in, they come and visit their houses. You'll actually notice some of the houses in the villages look quite freshly painted. And that's because some of them bring paint with them just to paint the house, so it feels a bit like it's still their property, they're still taking care of it. And when they come back in, obviously they want to see that things are as they left them. So there is this concern that people do come into the zone sometimes and they take things with them, they take artefacts with them. Now, ethically, that's quite questionable because you are taking somebody else's property and it's things that they may well want to see again when they come back. So you sometimes see photographs, for example, inside some of the abandoned houses. But those are photographs that they may well want to see on the wall the next time they come back.